Let's find mean, median, and mode of a group data. Supposedly, we have this table, all right? It consists of this first column, which is the class intervals, and then on the second column, it has frequency, and this frequency has its own class interval, and vice versa. So how do we get the mean, median, and mode in this one? So before that, let's look first at class width. First, what is class width? Class width is basically the number of values in a class interval. So here's the thing, okay, to ask you in a different way. How many values are there in that class interval? All right. So let me give you the second question that I would like to ask it to you. Why is it important to find the class width instead of directly finding the mean, median, and mode? Do you guys have any idea? So if you guys don't have any idea, then I'll say mine. So for me, in my opinion, finding this class widths basically give us, again, number one, the number of values in a class interval. Because what would be the number of values in a class interval is present, that will be also the number of values present in other class intervals. For example, the number of values here is 4. Therefore, the other intervals have the same class width as the first one, which is 4 as well. All right, meaning each of these class intervals are equally distributed. Therefore, each of them has the same width as the other intervals. Because before making this table, which in fact it has class intervals, make sure that these class intervals has the same class width as the others. Right. And last reason is that in other methods and formulas, class width is present. So for me, it is a top priority to know your class width. All right. So what are the ways on how would you get that class width? So there are four ways, but I'll just introduce the first three because the fourth one, it's gonna be later or soon, as we progress in this discussion. So the first way is just basic counting. Just pick any interval here, right? Because I told you before that what would be the number of values here is the same thing as the number of values in this interval and two others as well. So I'll pick this interval, 10 to 15, this one. So I'll count from 10 to 15. So 10, 11, 12, 13, 14, 15. So meaning I have 6. So there are a total of 6 values in a class interval. Okay. So that means in other intervals, it also has 6 values. Just like this one, 16, 17, 18, 19, 20, 21. Oh, see? So meaning there are 6 data given in a class interval. All right. The second method is by using upper class limits. All right. So first and foremost, what is upper class limit? So upper class limit is basically a value that is present as the last value in a certain interval. So, for example, in this interval, 10 to 15 interval, so the last number present is 15. Okay. So 15, 21, 27, and other numbers. Okay. That is the last representative of that class interval are what you call as the upper class limits. All right. So how can I use this one as a method to find a class width? So I'll just pick any upper class limit except this one, this one, all right, this one, right? So I'm just going to pick from here to here, all right? So let's just say I pick 27, all right? So I'm going to subtract 27 by its previous upper class limits, all right? So 27 minus the previous upper class limit, which is 21. So 27 minus 21 is equal to 6. And it's just the same as what we did before. Or you can pick any upper class limits. Or make sure they are stick together, or like consecutive. Okay, like 39, 38, 45, 39, and so on and so forth. The third one is just as similar as the second method, but instead of upper class limit, we're going to use lower class limit. So what is lower class limit? Lower class limit is basically the beginning of the interval, like the beginning value of that class interval. So for example, in this interval, 10 to 15. So the beginning value or the starting value is 10. All right. So 10, 16, 22, and the rest of these values that are the beginning of that interval are what we call as the lower class limits. All right. So by getting these class widths, all right. So again, we're going to pick any lower class limit except the first one, right? Except the first one. So starting from here. So let's just say 22. I pick 22. So 22 minus its previous lower class limit, which is 16. So 22 minus 16 is equal to 6. That's it. You can pick any lower class limit, all right? The main reason why I don't include this one because first and foremost, let's just say I'm going to pick this as the lower class limit I use. So here's the problem. Okay, what number I will subtract this one to get the value of 6? You know what I mean? Like if this one, let's just say 46, I can subtract it with 40. How about the beginning 10? Right, where would I subtract it? Right. So that means I'm not going to use the first one rather. All right. So yeah, that's it. All right. So we cannot proceed in getting the mean, right? Because later on, we're going to use this class width soon. All right. So yeah, remember that your class width is equal to 6. All right. Let me erase this one. All right. So let me put it here. So how do we get the mean? So the formula of the mean is equal to the summation of all the products of frequency and class mark midpoint divided by n, where n is a total number of data given, gathered, or collected. We can just simply equate n to the summation of all frequencies. Because if you're going to add all of the frequency, if you're going to look back at the table, it gives us the number of data given in a distribution. All right. It gives us the number of data that is being gathered by the researcher or by you. All right. So therefore, if we're going to add these frequencies, which give us a total of 75, therefore n is also equal to 75. That's it. So it seems like we found the value for n. How about for this one, the summation of all the products of frequency and class mark midpoint? So the first thing we need to do is make another column for class mark midpoints. So we're going to find class mark midpoint in each class. So how are we going to do that? What would be the formula to use to find a class mark midpoint in each class? So simply use this formula. Class mark midpoint, or CM, is equal to the sum of upper class limit, or UCL for short, and lower class limit, or LCL for short, divided by 2. All right. Basically, UCL plus LCL divided by 2. All right. Again, upper class limit is basically the last value present in the class interval. Lower class limit, on the other hand, is the beginning value, the starting value. All right. So, what is the class mark midpoint of this interval? This the first one, the first interval, 10 to 15. So basically, my upper class limit 15 plus lower class limit 10 over 2. So you're going to have an exact value of 12.5. That's it. So let's try the next interval, 16 to 21. So we're going to use the solution at the top. So yeah, okay. So upper class limit, which is 21, plus lower class limit, which is 16, divided by 2. So in this one, wait, I'm using calculator, I'm sorry. So in this one, we're going to have an exact value of 18.5. And we're going to do the same thing to the rest of the intervals, or class intervals, I mean. However, it's going to be tedious and hassle because you're going to use the same formula again and again and again. So is there a shortcut method? Yes. And what would it be? By using your class width. That is why I recommended you guys to find this one. All right. So what's the purpose of using class width and getting the class mark midpoints? Because it is like getting the arithmetic sequence actually. All right. Let's try this one. 12.5 plus the class width, which is 6. So 12.5 plus 6 is equals to 18.5, which is the next class mark midpoint. So if we're going to add 6, okay, to 18.5, we're going to get 24.5, which is the next class mark midpoint. So let's keep on doing that. So 24.5 plus 6 is equals to 30.5. So this will be 30.5. And let's add by 6 again. So this would be 36.5. And yep, 36.5 will be the next class mark midpoint. Let's add 6 again. So we're going to have 42.5. And let's add 6 again. So we're going to have 48.5. There we go. And we're going to stop right here because that's the what last row or the last class interval. So that's it. And we're going to erase this one. And that's how we got your class mark reports. See? Shortcut. I told you guys earlier, in other methods or formulas, class width is present. So this method is actually shortcut so that you can fill in the other class mark midpoints. So now that we completed in filling in these class mark midpoints, now we're going to make another column, which is getting the product of frequency and class mark midpoint in each class. Meaning, for example, in this class interval, we're going to subtract each frequency by its class mark midpoint. And same thing to the other class intervals as well. So let's do it slowly, but surely. All right, so let me erase this one so that I can have more space in filling it. So 10 times 12.5 is 125. Next, 12 times 18.5 is 222. Next, 11 times 24.5 is 269.5. Next, 21 times 30.5, we will have 640.5. Okay, next one, 16 times 36.5, 584. Then 3 times 42.5 would be 127.5. And last but not the least, 2 times 48.5 is 97. That's it. Right? That's it. Okay. So now that we completed this column, which is basically the product of frequency and the class mark midpoint, now what we're going to do is to get the sum of these products, which is the sum of all the products of frequency and class mark midpoint. So let's add them all. 125 plus 222 plus 269.5 plus 640.5 plus 584, if I'm correct. Hold on. 16 times 36.5. Yep, 584. Where was I? I'm sorry. 269.5. which is 14.5, 584, 127.5, and 97. So we will have a total of 2065.5. That's it. All right. So, okay, there we go. So the last step is just basically substitute the values because since we already got the missing value left, all right? So let's substitute. This is 2065.5 divided by 75. So we will have the mean of 27.54 exactly. So this is the mean of this group data. So that's good. Now, how about for the median? Now let's find the median. So for the median, we're going to use this formula. Lower boundary of the median class, or median for short, plus quantity n divided by 2 minus less than cumulative frequency before the median or before median all over the frequency of the median class times the class root, which is basically 6. So it seems like we have a lot of things to figure out or to determine, like the lower bound of the median class, and frequency of the median class, so on and so forth. All right. So before that, the first thing we need to do is let's make a column for less than cumulative frequency. All right. So I'm going to make another column, and this would be less than cumulative frequency. So how would you make less than cumulative frequency? So we're going to start at the frequency of the class interval that has the lowest values. So here we have 10, right? And 10 is basically located, or let's just say found in the class interval of 10 to 15, which is basically the first class interval that has the lowest values. Because as you can see, um, in each interval, it's increasing, increasing, increasing. Like this one, 10 to 15, 16 to 21, 20 to 27, so on and so forth. So we're going to start from the below, which is 10 to 15, because this class interval has the lowest values. All right. So therefore, we're going to start its frequency, which is 10. So we're going to start 10. There we go. So how can we get now the next cumulative frequency? So what we're going to do is that we're just going to add 10 to the next frequency of the next class interval. So 10, right? So 10 plus the next frequency, 12. So 10 plus 12 is 22. All right. Next, 22 plus the next class interval, which is 11, which is basically 33 as a result. Next, we're going to do the same pattern again and again, all right, which is 33 plus the next frequency, 21. So this is 54. Next, 54 plus 16, all right? So this one would become 70. And we're going to do the same thing all over and all over again. So yeah, it is quite long, forgive me. So 70 plus 70, oops, I already said the answer. 70 plus 3 is 73. And last but not the least, yeah, 73 plus 2 is equal to 75. And that's it. And we're done, right? We're done. Okay. So the next step is we're going to find the value of n over 2 basically we're going to divide 75 by 2. So n over 2, okay, which is 75 over 2 will give us the value of, wait, so yeah, 75 divided by 2, 37.5. Yes, I'm correct, 37.5. So now the next step here is that we're going to locate the median class. So how are we going to locate the median class? Right? First thing is that, right, we have 37.5. And now we have the column for less than cumulative frequency. So now we're going to pick two consecutive cumulative frequency wherein this value is located in between them if ever you're going to make an interval. Again, all right, we're going to locate two consecutive cumulative frequency wherein this value is located in between them. All right, so let me say it again. Pick two close cumulative frequency wherein this value is found or located in between of these two numbers. All right, so 37.5 is located in between 33 and 54. All right, 33 and 54. All right, because if you're going to make an interval from 33 to 54, it will have numbers like 33.3, 34.5, 36, 37.5, etc. All right, so that's a good thing. All right, you located 37.5 in between these two consecutive cumulative frequency, which is 33 and 54. So now the next thing is use the largest one, which is 54, the largest value, and now locate its class. So 54 is located at the class of 28 to 33 interval. So this class is your median class. So that's it. 28 to 33 is your median class. There you go. That's it. So now that we knew our median class, let's find the lower boundary of the median class. So how do we get the lower boundary of the median class? So by getting the lower boundary of median class, just get its lower class limit and subtract it by 0.5. Alright? So the lower class limit of the median class is 28. Remember that lower class limit is the beginning value of the class interval. So in this class, or specifically median class, the beginning value is 28. So 28 minus 0.5. So 28 minus 0.5 will give you an exact value of 27.5. Yeah, I'm correct. So that's it. All right, that's good. Now next, we're going to locate the frequency of the median class. So the frequency of the median class, just basically look on the right. Like if this is the median class, then look next to it, which is the your frequency. So as you can see, the frequency of the median class is 21. Therefore, the answer or the value for that would be 21. That's it. And last but not the least, we're going to find, hold on, let me erase this one. Last but not the least, we're going to find this one. All right. So since I have no space, I'm going to write here. That's okay with you all. So less than cumulative frequency before the median class. All right. Or let's just say before. All right. I would rather just write before since I have no space here. Just remember, it's before median class. All right. So, right, 54 is the value that I used, all right, or the largest value that I used to locate the median class. Now, we're going to find what's before it. So before 54, we have 33. So that means that would be the cumulative frequency before the median. So that is 33. All right. Again, how did I locate this less than cumulative frequency before the median class? Right, we use 54 as the largest value to locate the median class, which is 20 to 33. Now, we're going to locate it by looking what's before it. So what's before 54? So it's 33, right? So therefore, the cumulative frequency before the median is 33. So that's it. So now we're going to substitute. So since I have no longer space, I'm going to erase this formula. But don't worry, I know, I know where will I put it. All right, like what is the lower boundary median? Where will I put it, etc. All right, I know the position of what value I'll put it in. So I'll erase this one, and I hope you take this formula in your notes. All right. So I'm going to erase this one. All right. Excuse me. Okay, hold on, hold on, hold on. Wait. That's it. So I substitute. So the first thing here is what? Lower boundary of the median class, which is 27.5 plus here n over 2, which is your 37.5 minus less than cumulative frequency before the median, which is 33, all over the frequency of the median class, which is 21, times the class width, which is 6. So I'm going to use my calculator. So the value with 37.5, correct, 37.5 minus 33 divided by 21 times 6. We're going to have an approximate value of 28.17. That is the median for this group data. All right. Now we're going to proceed the last one. How will you find the mode of this group data? Now that we're going to find the mode, this is its formula. So by getting the mode is basically lower boundary of the mode class plus delta 1 divided by the sum of delta 1 and delta 2 times its class width. So again, the class width here is 6. All right, that's it. So the first thing is we need to know what is our mode class. All right. So how would you determine the mode class? So by getting the mode class, just basically pick the class interval that has the highest frequency among all of the class intervals. All right. So look at this one. All right. So we have these class intervals, then we have these frequencies. So each of the class interval has its own frequency. So this one, 20 to 33, has a frequency of 21, and 21 is the largest value among all of the value frequencies given. Therefore, this class interval, has the value of frequency that is actually the highest. Thus, this is your mode class. Your mode class is 28 to 33. So this is your mode class. There you go. Okay. So now that we determine the mode class, we're going to figure out the variables, such as this one, lower boundary of the mode. So let's start with this one. So the lower boundary of the mode, again, just get its lower class limit and subtract it by 0.5. So the lower class limit of the mode class, which is 28, all right, and minus 0.5, that will give you 27.5. That's it. So the lower boundary of the mode class, which is 28 minus 0.5, 27.5 it is. All right. Next, delta 1. What is delta 1? Delta 1 is basically a difference between the frequency of the mode class minus frequency before the mode class. How I wish I could write before, but if you want to get what I mean, I'll just write before mode. All right. So again, this is the frequency of the mode class, and this one, frequency before the mode class. So what is the frequency of the mode class? So since this is your mode class, its frequency is 21. All right, minus the mode class, the frequency before the mode class is 11. All right, this one, 11. Here's the thing, why not 16? Why not 16 instead of 11? All right, look at the order of these class intervals. Look at this one. I think I mentioned earlier that this interval, like, is the class interval that has the lowest values. And as you can see, if you're going to proceed to the next class interval, right, it increases the value from 10 to 15 to 16 to 21, from 16 to 21 to 27, to 22 to 27. So it keeps on increasing and increasing and increasing. All right. So as you can see, the order here is what? Ascending from lowest up to the highest. So a class interval that has the lowest values up to the class interval that has the highest values. So therefore, it is arranged in ascending order. So therefore, if I have 20 to 33, then what comes before it is 22 to 27 interval. So therefore, the frequency before the mode class is the frequency of the 22 to 27 interval, which is 11. All right. So we're going to subtract this one. 21 minus 11 is simply 10. Now, last but not the least, delta 2. So for delta 2, it's just similar as the first one, but instead of getting the frequency before the mode class, we're going to get the frequency after the mode class. So here, F mode minus F after mode. All right, after mode. Since I have no space, I'm going to move it right here. Forgive me. So frequency of mode class is 21. Now, how about after the mode? So since you see the order is ascending, therefore, what comes after this interval, okay, that would be this interval. And we're going to get its frequency. So right here, we have 21. So what comes after 21 is 16, all right? So as I told you again, the order here is by ascending. So again, 20 to 33, okay? So what comes after this interval is 34 to 39 interval. So we're going to get its frequency, which is 16. So that would be the frequency after the mode class, all right? So 21 minus 16 is and we're done, right? We're done. So what we're going to do now is substitution, which is the last step. So lower boundary of the mode class is 27.5 plus delta 1, 10, all over delta 1 is 10 plus delta 2, 5 times 6. Wait, hold on, let me just go 5 times 6. So I'm using my calculator, forgive me. So 10 over 10 plus 15 times 6. So we're going to have an exact value of 31.5. And that is the mode on the group data. And that's it, guys. So these are the mean, median, and mode respectively. All right. So thank you for listening. And once again, I am at Angel Vade. I'm always here to guide you in answering mathematics. See you.